Okay, lesson 25. These are all word problems. First one says Tom is 6 times as old as Todd. In 6 years, Tom's age will be 12 years more than 3 times as old as Todd. So how old is Tom? First thing to do is to assign a variable. So I'm going to use X for Tom. They both start with a T, so I don't want to use that. So this is Tom now, and Y, I'm going to use Todd now. So you want to always make the variable their age now. So it says Tom is 6 times as old as Todd, so X is 6 times Y. Then it says in 6 years, so that means Tom in 6 years is going to be X plus 6. It's going to be 12 more than Todd, so it's going to be Todd in 6 years, 3 times Todd, I'm sorry, and it's 12 more than that. So simplify this. So this is going to be 30 minus 6. And then take this one and plug in there. Because remember, this is your first equation. This is your second. So you get 6y equals 3y plus 24. So subtract 3y from both sides. And so you get that Todd is 8. But I want to know how old Tom is. So Tom, I know, is 6 times 8. So Tom is 48 years old. Okay? Okay. Next one. Brad is 4 more than 3 times as old as Henry. So I'm going to use B for Brad. So this is Brad's age now. And H for Henry. So this is Henry now. So it says Brad is 3 times as old as Henry. Yeah. In 7 years, the sum of their age, I'm sorry, is 4 more than that. I didn't put that on there. In 7 years, the sum of their ages will be 62. So in 7 years, Brad's going to be this, and Henry's going to be this. If you add it up, it says there'll be 62. Okay, this is equation 1, this is equation 2. Simplify this one. This is 14, subtract it from both sides, and you're going to get, yeah, 44, right? I mean 48. Excuse me. Yeah, you get 48. Okay, then I want to take this one and substitute it in here. So I'm going to get 3h plus 4 plus h equals 48. So then add these together and subtract 4 from both sides, and you get that h is 11. And I want to know the age of Brad now. So Brad, how old is he going to be? Well, I'm going to use this right here. So B is 3 times 11 plus 4. So that's 33 plus 4. So Brad is 37 years old. Okay, next one. Train A leaves the station traveling at 64 kilometers per hour. 6 hours later, train B leaves the same station traveling in the same direction at 84 kilometers per hour. How long does it take train B to catch up to train A? So the first thing I want to think about is the distance that both of them traveled. So although they left at different times, they left the same station and they caught up at the same time. So the distance for train B is the same as the distance for train A. Then I can substitute rate times time for each one of those. I also know the rates of each one of them. Train A's rate is 64, and train B's rate is 84. I also know that train A left 6 hours earlier than train B. So the time for train A is going to be 6 more than the time for train B. So I'm going to put that right here. Okay, now I'm down to one variable. I'm going to do distributive property. So I'm going to subtract that from both sides. Now I want to divide both sides by 20. And when I do that, I think I get, 19.2 hours. And that was how long does it take. So 19.2 hours. Okay, let's see. Turn it over. Number 4. Driving a tractor, Larry can plow a 1-acre field in 6 hours. So the rate for Larry is 1 in 6. Sarah can plow 1-acre field in 12 hours. The rate for Sarah is 1 in 12. It says if they work together, how long to the nearest hour will it take them to plow a 1-acre field? So the rate times the time is how much they get done. So, but the rate is a combined rate, so add their rates together. Times the time and how much they get done is 1 acre. Get a common denominator here of 12. You get 2 twelfths plus 1 12. That's 3 twelfths. That's 1/4. So time is going to be 4. So it would take 4 hours of them working together. Okay, number 5. While building a new apartment complex, the work crew found that it took 4 people to frame 5 apartments in 7 hours. So we're going to use a workers times rate times time equals job setup. So the number of workers to start was 4. The hours it took them was 7. And the job they got done was 5 apartments. Now we don't know their rate. I'll put that right there. So that's 28R equals 5. So their rate when they all work together like that is 5 over 28. Now, the next thing says he added 10 more to the job. How many hours would it take them to do 60? So 10 more than this, 10 more. That's 10 plus 4. So we have 14 times the rate that we already figured, 5 over 28. I don't know the time, and I know it's got to be 60 of them. So 14 goes in 2 times. Multiply both sides by 2 over 5, and you'll get 24 hours. Okay, number 6 says one machine can make 40 levers in 8 minutes. So the rate for machine 1 is 40 in 8, or 5. Another one can make, that's the second one, it can make 36 in 9 hours. That reduces to 4. It says the second machine began making levers 5 minutes before the first one began. So the second machine is making levers. So it's his rate times his time is how much he got done by himself. His rate, it said he did it for 5 minutes. So he got 20 done. It says then the first one began. So that means they began together. So then they're working together. So you add their rates together times their time. So if I add their rates together, 5 plus 4, I get 9. It says how long is it going to take them to do 164? So that's going to be the total they want to get done. So it's got to equal 164. So subtract 20 from both sides, and it's going to take them 16 minutes. Okay.